Hello, everyone, and thank you for joining us today. My name is Alexandra, and I will be your webinar host, which means I will be handling all of your Q&A. During the presentation, we have enabled the questions panel, which you should see at the bottom right-hand corner of your screen. You may need to push the plus sign to expand the panel. This session is being recorded and will be made available for all attendees should you care to listen to it again or share it with colleagues. Now, I would like to introduce our speaker for today, Vice President of Product Management, Scott Register.
Thank you, Alexandra, and thank you everyone for joining us today. Again, my name's Scott Register. I'm with Ixia, and I realized I didn't put my email address on the slide here. It's sregister, first initial last name, at ixiacom.com. If you have any follow-up questions, feel free to send them in. So, get started here. For those of you who are not familiar with Ixia, a lot of our background is really in the test, like the IP testing space. And through an acquisition called Breaking Point, which is actually where I came from, we have been and continue to be the gold standard for security testing. And this means if you're the manufacturers of firewalls or IPSs or routers or basically any other networking gear, even mobile equipment, but especially security gear, nothing leaves the lab, nothing leaves QA until it has been validated with Ixia's security test gear. And in order to support those efforts, coming up with latest malware samples and latest attack techniques and all of that stuff, we've got a team of a couple of dozen full-time security developers spread out across the world who focus on staying on top of the new latest kind of greatest trends in security and attack techniques and all of those things. And as we expanded more into network visibility and moved more into the production network side, we started thinking, well, how can we take all of this great security expertise and all of this research that we do and bring it to customers in a way that can help make their networks safer and more secure. But we didn't want to build just a firewall or an IPS. There's plenty of those out there, and they're fine. And so we looked and said, okay, what's really going on in the world? And we realized, well, you read about breaches all the time. You hear about them, and there's many, thousands more that you don't hear about. There's Target, Home Depot, and Anthem. I mean, there's zillions. Ashley Madison, hopefully nobody was caught up in that. So those things are happening all the time. But all those companies, all the things you read about, and even all the ones that you don't, they all had firewalls and IPSs, and often they had a SIEM, which is a security incident and event manager, kind of a log aggregation device for all their security things. They all had those in place, right? So they all had security teams, they all have security tools, and hackers, they may be skillful, but they're not invisible, right? They leave trails, they leave digital footprints of what they're doing in the network. But despite that, and despite all these tools being deployed and teams operating them, breaches still happen. And we say, okay, so why is that? Well, we realize that when you look at all the flood of kind of security alerts that you get on your IPS or your SIEM, et cetera, we found plenty of research to back this up. About 71% of those security alerts are effectively ignored. And they're ignored just because you get so many alerts every day, and you may have heard this as a term like alert fatigue or alarm fatigue. You get so many of those every day, you can't possibly track them down. I think on industry average, it takes about an hour and a half per alert to kind of run it to ground to see if it's real or not. Obviously, the variation in that is quite high. Some things that could take multiple days, some things you can dismiss quite quickly. But on average, it's going to take you time. So if you get, let's say, 10,000 alerts a day, which is certainly not unrealistic, you're going to have to let some of those go by. You're going to have to let some of them go uninspected. You make basically a manual effort, apply some heuristics, try to get the most important stuff, but some things are going to get passed. And one of the side effects of this is the mean time to breach detection. Like if you've got an active breach in your network, the time it takes to figure out, hey, there's something going on, is about 6 months. And in fact, most enterprises don't even discover themselves that they have a breach. They're told by a supplier, by a customer, or by a law enforcement agency, right? And so this is a big problem. The flood of kind of security noise, whether it's port scans or probes or botnet activity, whatever, they're all real, they're all security things, but most of them aren't actionable. You don't need to actually do anything. This is a big problem because it makes it impossible to find that important stuff. And what causes this is, there's so much traffic in and out of your security perimeter every day, and it's growing all the time. And there's a mix, right, of there's people doing their jobs, doing their business, doing email. But think about it, your laptop on your desk can easily have 30 to 40 connections going on all the time, right? You've got all those little apps running in your taskbar and things fetching updates and fetching, your Twitter feed and all these things happening. So there's lots of connections, and then embedded in some of those, there's going to be malware, and there's going to be, brute force SSH and telnet attacks coming in. And if you've got some active malware on a tablet or on your laptop or something, it's going to be trying to both connect to other internal systems and trying to connect outbound, to register, to phone home, to download instructions, to maybe leak information out. And all of that stuff kind of going through your security perimeter is setting off, is going to be setting off alerts all the time that you're having to deal with. And because that alert volume is so high, again, it's just impossible to find that needle in the haystack, that critical event, that thing that you really need to see to say, hey, I've got an active breach. This looks bad. I see, 4 systems in my network that are actively communicating with some botnet controller. There's communication going both ways and probably leaking data. I need to go stop that, right away and get on it. And it's just because, again, it's really lost in the noise. So quick question here, Alexandra, I'll pass over to you.
Well, thank you, Scott. I'm going to launch the poll for everybody. Your use of SIEM, is it, I don't have a SIEM deployed, I have a SIEM deployed and I have no trouble keeping up with it, or I have a SIEM deployed and there's no way I can keep up with it? I'll give you guys about 30 seconds or so to make your selection. All right, it looks like almost everybody's selected an answer. So, Scott, it seems that about 50% of the audience does not have a SIEM deployed, about 19% have a SIEM deployed and they have no trouble keeping up, and about 31% have a SIEM deployed and they cannot keep up with all of the demand alerts.
All right, thank you. So that's interesting. This is actually the closest it's been. The typical ratio has been about 2 to 1. People saying no, they can't keep out versus the ones who can. And I realized, after we started doing this, that the question here is really specific to SIEM, but in our experience, even like if you think about IPS alerts, I think that you tend to see the same kind of pattern. There's so many alerts there's so many things going on that they're typically hard to keep up with. Most people, without having a large security team, like a really large security team, there's just not enough time to do it all. So this is the problem that we decided to focus on. How do we cut down that volume? How do we get rid of a lot of that kind of security noise so that people can be much more effective? And we said, okay, we do all this security research, we have all these people working kind of on the problem all the time. What if we could build a database, a massive database of every site, every IP address basically on the internet that we know is bad, is doing malicious activity, is a phishing site, is a botnet herder, like it's something that's going around and scanning for weak devices, or is a botnet controller, or is a hijacked site, things like that. And for good measure, what if we let you say, okay, this is the network where my users sit. I really don't do business with, we'll pick North Korea, right? So there's no reason for someone in my network or a piece of software in my network connect out to North Korea, and there's no reason from someone from North Korea to connect into my network, right? If you could get rid of all of this known bad traffic and all these countries that you don't do business with or don't trust, that could have a dramatic effect on the number of security events that you have to deal with. One of the things that actually makes this really effective is, especially in the IPv4 world, we're out of addresses, right? There are no more v4 addresses to hand out. I mean, they just have to be recycled, right? And that means that if you're a bad guy and you need some, IP address to host a botnet campaign, for example, it's either going to be expensive in terms of either time or resources to go hijack a site or buy a legitimate, IP address, or you're going to reuse the same site over and over. And that's what we find. We find really high reuse rates between malware campaigns. So by detecting, hey, there's a campaign here, a particular botnet is connecting back to this site, we say, okay, that's bad, you can block that. You will block subsequent attacks even without knowing about them, just because that IP, that site is being reused. So if you can do that kind of blocking, you get huge gains in efficiency, and you can save tons of time. So the average kind of larger enterprise in the U.S. spends about 21,000 hours a year tracking down security alerts. Now, this is false negatives, false positives, real, actionable alerts summed together. That's a fair amount of time. And so if you could conservatively eliminate a third, and for us that's definitely a very conservative number, but if you can eliminate a third of those alerts, that will save you, a significant number of years, over 6,000 hours per year. In our case, if we can do that, that gives you a 15x ROI. So, this is a product that basically pays for itself in less than a month. That's pretty significant. And so that's what we've done in this new product that we call ThreatArmor. So you could think of it as a threat intelligence gateway, a gateway device that takes all this great threat intelligence and automatically applies it to your network to get rid of IP addresses and in some cases domains that we know are bad, or countries that you don't trust. And by doing that, you can reduce this alert fatigue and have far fewer things to go track down, and that makes your network safer, and you're blocking attacks, and you're making your tools more efficient. And the way we do this, a typical deployment looks like this. So the ThreatArmor device sort of wraps around your existing security infrastructure, your firewall, your IPS, etc. On the outside, it's blocking all the inbound, Telnet and SSH brute force attacks and network probes and connections from hijacked IPs and things like that. And on the outbound side, if you have an active malware infection in your network that's trying to phone out to kind of phone home, download instructions, download new binary, leak information out, not only will we stop that, but because you're inside, or we're inside the NAT gateway of the firewall, we can tell which internal systems are compromised. And when you come in Wednesday morning, you see, oh, these 5 systems on the inside of my network are all trying to connect to this botnet controller on the outside. Hey, I'm already blocking those connections, so I'm safe, but those are the 5 systems I need to go clean up right away. Similarly, if someone clicks on a phishing email, or they click on a link that will take them to an IP address that's been hijacked, right? So the website there is no longer operated by its rightful owner because that that network has been hijacked somewhere halfway around the world. We'll stop that connection for you and let you know that it's happening. Now, one of the questions that we get fairly often is, how does this compare to a firewall, right? I've got a next-gen firewall and it advertises this threat blocking capability. It may have threat feeds that you can plug in, etc. So how do we compare? It's a very valid question. The reality is, and I've been in the firewall space for a couple of decades now, firewalls are really good at deep packet inspection, at looking at a connection, maybe looking for malware inside it, for doing things like web security, filtering URLs, user-based policies, who can go to what site, VPN terminations. I've got a mobile user and he wants to connect into the network and access certain internal things. They're great at that. They're really good at that. But because their architecture is built for DPI, they're really not optimized for large-scale IP blocking. I mean, a typical kind of entry to mid-range firewall will get you maybe 10,000 quote network objects, which can be an IP address or an IP range. On the very high end, if you spend, maybe 200 grand, you can get up to 40,000 ranges. That's certainly the highest that I've seen. But even at that level, you're nowhere near the size of the ThreatArmor rap sheet, what we call the rap sheet database. So you're not even in the same ballpark as ThreatArmor. In fact, we built ThreatArmor, out of the gate to effectively have a rule for every IP address on the internet. So it doesn't matter if you're blocking 1 or 1,000,000 or 1,000,000,000 sites. We always have line rate performance. Doesn't matter what your packet size is. We're not going to slow down. Doesn't matter how many things are in our database or a new one that you add to us. We'll block it. We never slow down. If you're going to try that on a firewall, you would definitely run into some serious memory and performance limitations. We've also found that if you were trying to do that kind of large-scale blocking on your next-gen firewall, and you offloaded that, you stopped trying to do it there and put it, just allowed ThreatArmor to do that kind of blocking, and that's what it's optimized for. Not only will the performance on your firewall go up, you can often enable advanced features that you would not have been able to otherwise, just because we've taken so much load off of that device. So next question, well, where do we get all of our security information? So as I mentioned earlier, we've got a team of researchers, again, a couple of dozen who do this for a living. We operate honeypots. We've got our own scanning probes. We do our own malware engineering research, and we reverse malware samples that we find. We do accept feeds from lots of different places, from public sources and private commercial feeds and industry partnerships and things like that. So there are a lot of kind of raw, kind of candidate sites that go into our database, or that go into our system. But what really separates us from most kind of threat intelligence feeds and the way that they operate is we individually validate every single site in our database every day. So we have a great deal of concern about false positives. We want to make sure that we avoid those. So every site that we block, we go and recheck every single day to make sure that it's still bad. And if we find after 3 days that the site has been cleaned up, we remove it from the blocking database. So anything we block, we have very high confidence in, and we show you on screen exactly why. So we'll say, hey, this site that someone just connected to, here's this 8 specific pieces of malware that we ourselves have found today being pushed from that site. Here's the download URL. Here's the checksum of the file if you want to compare it at VirusTotal. If it's a phishing site or something, we'll say, hey, here's a screenshot of the site that pretends to be Bank of America but isn't. Here is a screenshot of the installer on if it's a malware that actually has a visible installer. Here's a screenshot of that happening. If it's a brute force attack, we'll say, hey, here are the specific username password combinations that we've seen this particular scanning host use today, and we show you the last scan date and all of that, along with things like connection stats and details. So we're very, very focused on 100% assurance, and if we aren't 100% sure that a site is bad, we don't block it. So basically the fear of false positives go away, and you can know anytime we block something exactly why we've done it. So if you think back to the kind of the beginning of the conversation where I was talking about alert fatigue and the amount of time you have to spend tracking down security incidents and things like that, if we took a lot of time to operate, we wouldn't be doing you any favors, right? Because our goal is to give you back time, not take it away. So we've tried to make this very, very easy. There's no rule-based to configure, no user-based policies, things like that. It's a quick setup, and then it auto-updates every 5 minutes by default. The ThreatArmor device goes out and queries the cloud, sees if there's new threat information. If so, it downloads it and keeps running. So you set it up, and really you don't have to touch it very much. So we use a memory map system that basically let the packet come in, and then we map if it's an inbound packet, we map the source IP of that to a memory location. So instead of having the traditional firewall or like router ACL mechanism where you get a packet in and you walk down a list of rules until you either run out of rules or find a match, we map that IP directly to a memory location. So it's A, very fast, and B, latency invariant. Doesn't matter how many of those things you have, we've got enough memory that we're not paging things in and out, we're not having to look down a list, so we can know very, very quickly and whether that site should be allowed or blocked, and it doesn't matter how many of those there are. Now, this is an inline device, obviously, so we built it to be as highly available as possible. One of the ways that we do that, one kind of product family that's now part of Ixia, is a company called NetOptics, which we acquired a number of years ago. And NetOptics really pioneered what's called a bypass switch. And for those of you not familiar, a bypass switch is a device you put on your network and you can hook things like firewalls and IPS and IDS up to it and allow for very flexible things like failover. It's basically a network availability device because you can say, hey, I want traffic to route through my IPS, but if I need to take that IPS down or reboot it or perform an update or for some reason it dies, I want zero interruption in my network. I want packets to keep going and just fail around that. Or maybe I want to have an active-active or active-passive configuration. It allows you to do that fail-to-wire that keeps traffic going. So what we've done in ThreatArmor is we've taken that same technology and integrated it into the onboard Ethernet interfaces. So if through the UI or the front panel buttons, or even if you walk up to the system and pull both power cords out, and it does have dual redundant power, traffic keeps flowing, right? So we're very, very focused on that availability aspect. Also, it's worth noting that the ThreatArmor subscription, which includes like threat updates and geolocation updates, also includes not only unlimited phone and email support, but also advanced RMA. So if you ever have a problem with a system, you call us up, we send you a new one, you send the old one back. It takes about 30 minutes from cutting the packing tape to having ThreatArmor up and running. And we actually used some teenagers, kids of employees, as our beta test site. So we're pretty comfortable in that number. Basically, you just wire up the dual power supplies and the Ethernet cables. You can see what the typical deployment looks like here. What I've shown here is really the inline deployment. You can also run this hooked up to span ports or taps in just reporting mode. And even if you wire it inline, you can run in reporting mode. In fact, that's the default mode of operation. So if you want to see what we see on your network that we think should be blocked, but not automatically do so, if you want to make sure everything's connected correctly, maybe you want to go validate some of the block sites yourselves just to learn more about them, you can do that. And then when you're ready to really get the maximum benefit from ThreatArmor, you just click on reporting mode there in the UI, and it will change modes. And then you can walk away. You don't have to configure any policies. You don't have to do anything, and it will go and fetch updates automatically every 5 minutes. All of the malicious site blocking is automatic. There's nothing to configure there. The only thing you would need to manually configure, we do allow whitelisting and blacklisting, so maybe there's sites you want to allow access to even though you know they're bad. Or more commonly, let's say your own security team has identified certain external hosts that are attacking you, like you specifically. Maybe they're not in our database. You can easily import those either through a REST API or through a bulk import mechanism. So let's say you're in a service provider environment and there's 400,000 IPs that you want to block. You can do bulk imports of those. Also, if you want to block certain countries, you say, hey, I don't do business with Syria, wherever, you can click on that on a map and say, boom, take all traffic to or from there off of my network. So that's the only thing that you would have to configure yourself. All the malicious stuff is automatic. Oops. So I'm going to switch over now to rather than show screenshots, I want to switch over to quick demonstration. So here is the ThreatArmor user interface, and so this is actually a live up and running system. So I can see here what are the countries that I've blocked in the last hour or 24 hours or week. And so you can see like where where are kind of the hot spots for malicious activity that we're blocking. We also show you some statistics on number of block connections in that time frame, total number of connections, traffic volume of block traffic and allowed, also some real-time stats about throughput, active connections, link utilization, things like that. If you mouse over and click on a particular country, we'll show you, okay, within this time range, how many connections have I blocked, related to, in this case, China, how many packets was that, how much traffic did we actively block, how much did we save by estimate, et cetera, and what's the total amount of traffic to that geographic region. So if I bring up my dashboard here, I can see a little more detail. So some of the things that we show, I'll make this a little bigger, maybe a little easier to read. Some of the things that we show here are the top allowed countries. So this lets you see, okay, traffic on and off my network, where is it going to and from? So I can see here 65% of my traffic from this site is to the US, 1% is Canada, et cetera. The reason we do this is it's really an informational thing, but it might surprise you and you might want to track it down if, let's say, 20% of your traffic ends up going to, I'll just pick Brazil. That might surprise you. That might be something you want to go investigate further to understand why. Now, on the other side, the bottom allowed countries, this is saying in the last hour, I've had, one connection with Tajikistan, I've had one connection to Yemen, etc. The reality is, if you're only getting, let's say, one connection a day, from a certain country, the odds of that connection being legitimate are actually quite small. So basically, these countries are all really good candidates for geo-blocking. So you can just come in here, click on this country, and disallow it. So it might have been attack traffic, might not. Just the odds of it being legitimate are very low. And so if your concern is taking illegitimate traffic off your network to minimize the chance for a zero-day attack or some other attack getting through, that's a really good place to do it. So you also see here the last couple of things that we have blocked. You can see here a log of the most recent blocks, and you can load the last ones. We've actually also just added an export to CSV feature, so if you want to dump all of this to a file, it's really easy to do. But here on the right, you see this is what we call a wrap sheet. So this is saying for this particular site in Indonesia, this site tried to connect inbound. This little symbol means we found multiple threats at this particular site. And here we're showing you on screen, okay, for this IP, here's the particular URL, here's the date that we scanned it. So this would have been yesterday that we scanned this one. Here's the checksum for the particular malware for this virus that we found. And you see we found several examples. We also found, and this is probably why we blocked it in this case, that it's conducting SSH brute force attacks. So you see here the specific commands that that particular scanning site has been executing. I can see what local IP it was trying to connect to and other connection stats. So I can see that that IP address tried connections. There were, in this case, 5 of them. You can see changing port numbers, but the destination port was always port 22, so this was an SSH brute force attack. I can also show you very complete DNS information about that site. So here's the reverse lookup, here's the NS records, I can tell you the ASN number, I can tell you the service provider, here's the specific malicious host name that we found there. Here are also additional domains or host names that we've identified at that IP address, but from which we have not found malicious activity. I'll show an outbound example. The lightning bolt here means that it's a hijacked IP address. So that means that someone basically corrupted some internet routing tables and has appropriated IP addresses which either should have been allocated or belong to someone else to themselves. There's no chance that that traffic is legitimate. That's obviously something that you would want to block. Okay, I will, let's see, we'll switch back over here. Okay, so one of the features that we've recently added is central management. And so the reason for doing this, obviously, you could have a big deployment, you could have a dozen, you could have 50 thread devices spread around the world. You want to make that really easy to manage. So we are hosting a per customer secure management portal. So you have your own dedicated management portal. You log in there. You set all the policies. So the exact UI that you just saw is exactly the same. You can see all of your aggregated block information. If you want to set a policy like block a certain IP or block a certain country, it's automatically pushed down to all your devices. You can see the status, the licensing information, when's the last time the device was synced, what's the operating mode, basically everything you could need to know about your distributed environment to make it really, really easy. So basically managing 20 devices is literally just as easy as managing one because you don't have to do anything on a per device basis. When you first log in, you tell it to use cloud management, and after that, everything is automated. Firmware updates, all that stuff you do through a single UI, and it pushes out to every system. We've also added a mobile client. This, just like the central management, this is free. As long as you're under subscription, you get it. There's no extra charge. The mobile client, it's a read-only version that basically shows you much of the same information you get through the full UI, just in summary form. So you can see the last things that you blocked and why you blocked. Oh, that was an exploit. Oh, that's an unassigned IP. This one was hijacked. The traffic stats, things like that. And it's just really a great way to get in anytime you're out of the office and see, hey, what's health of my system? Am I under attack? Is there something going on that I know about? Maybe I'm seeing a lot of outbound connections to a botnet controller. Hey, that means there's something bad on the inside of my network right now that I really want to go clean up. And that's available on the App Store. Okay, second survey here. Turn this over to Alexandra.
Great, thanks, Scott. For an on-premise security deployment with an ongoing subscription component, I would prefer to buy the appliance upfront and have a reoccurring subscription. I would prefer no upfront purchase, a reoccurring subscription only, or I would really prefer a software-only subscription-based model. I'll give you guys about 30 seconds or so to complete that poll.
Right, so obviously in this case, if you're going with, let's say the option B, you're getting the hardware, but you have a subscription, the subscription cost would be slightly higher than if you're buying the appliance up front. But the difference is there would be no upfront CapEx, it's OpEx only.
Great, it seems like a majority of you guys have voted, so I'm going to go ahead and close the poll. And you'll be happy to know that the split is even, 33% across each of the answers. So 33% for A, 33% for B, and 33% for C.
Wow, that's unbelievable, and it's interesting as we kind of do this in different geographies, how different their responses are. Some people have some regions have a heavy preference for virtual, but definitely the subscription thing has been very, very popular. So it's interesting that here is exactly evenly split across the board. That's actually kind of funny. I wouldn't have bet that ever would have happened. But thank you. Thank you for results. That's really interesting. Okay, moving forward. Okay, we have had some questions about the bypass switches that we make, and ThreatArmor, like, are they interoperable? Would you use them together? The answer is absolutely yes, and in many cases it does make sense to use them together. So I explained earlier the bypass switch, and what it does is basically a network availability device. So if the ThreatArmor device either fails, has power issue, software issue, or just through the UI or the front panel, you trigger bypass mode, it's fail to wire, and it's a mechanical fail to wire. So traffic keeps flowing. We're not going to interrupt your network services, but you might want to be able to plug or unplug the device. Now, obviously, that would have a network impact. Or maybe you've got both ThreatArmor and, obviously firewall, IPS, things like that. In that case, it might make sense to use ThreatArmor in conjunction with one of your bypass, like a bypass switch. So you could do things like on the left, you say, hey, I want to make sure that if either ThreatArmor or the firewall fails, I can just bypass, and really IPS might be a better example here, but I can just bypass the whole thing and keep network traffic flowing. Or in the other diagram, maybe you want to have single ThreatArmor device and then either active passive or active active for multiple other security devices. And so you route traffic through ThreatArmor and then through one or more security devices and load balancing or failover mode or whatever, and then back through ThreatArmor before going onto the internet. So really, if you're, we can certainly help you with that kind of deployment. Your local Ixia SE will be happy to assist you with this kind of configuration. It's just a question that we get a lot, so I wanted to go ahead and address it here. Yes, it's actually absolutely possible, and it often makes sense. Oh, and more importantly, because I do get this question, or similarly important, ThreatArmor doesn't take the place of a separate bypass switch because it's not going to protect you from something like IPS failure. It's really the ThreatArmor failover mode protects you from failure or something within the ThreatArmor system itself. Okay, so real-world case study. Service provider customer of ours, Hyperbox, pretty big network, they're getting millions of attacks a day, and so they were getting about 1 million IPS alerts every day, and trying to deal with this was a major headache for them. They were, first of all, there was no way they could keep up with 1 million alerts a day and know which ones were real, did they have anything to worry about, etc. And they were trying to identify, just by sorting their IPS logs, what devices were they, or what external IPs were they seeing the most attacks from, and then implementing blocks either on a router access list or on a host-based firewall, and they were running out of memory on their host-based firewall because they had over 300,000 of those, et cetera. It was a huge management nightmare and a huge time sink for them, and they were experiencing a lot of attacks, some successful, just because they couldn't keep up with that demand. Put ThreatArmor in with no tuning, no configuration. They weren't even doing geo-blocking. They immediately got rid of 80% of those alerts. And it's important to point out here that when we talk about getting rid of alerts, we're not doing it just by turning down the volume of alerts. We're getting rid of those alerts by eliminating the traffic that caused them, that traffic from the botnet controller, that outbound connection, to the controller, or the information leak, the network probe, the Mirai botnet scan that's looking for an IoT device that it can compromise, or a DVR, some other device on your network that it can compromise, an outbound connection to a phishing host or a hijacked IP. We're blocking those connections, and a lot of those connections would have bad things in them, and they're certainly illegitimate and don't belong on your network. So by blocking that traffic, we're able to reduce the threats on your network, reduce your attack surface, and make your security team much, much more efficient because they have to deal with so much less. And so that's really what ThreatArmor is all about. It's about automatically applying all this great threat intelligence to your network, keeping illegitimate traffic off of your network. If it doesn't belong on your network, get rid of it, right? There's no reason to waste inspection time, no reason to generate a security alert if it's something you shouldn't pay attention to at all. In fact, the analogy I usually think of is if you think about going through an airport, before and after 9/11. Pre 9/11, anybody could go through security, go to the gate, wave goodbye to grandma, when she gets on the plane. Maybe you weren't even taking a flight, you just had a penchant for overpriced bad airport food. Well, you go to the airport, walk anywhere you wanted, and do your thing. Now, you only get through security if you have a valid boarding pass, right? So ThreatArmor operates much the same way. There were always inspection devices and security guys at the airport, but they had to deal with a lot more people. Now that you don't have to have a boarding pass, those metal detectors and the guards, they're dealing with a much smaller set of people because they're only having to deal with people with legitimate travel requirements, that day. ThreatArmor is much the same way. We're getting rid of all of the illegitimate traffic, all the traffic that doesn't belong on your network, so your firewalls and security tools can focus only on the stuff that's potentially legitimate. And then inside that traffic, just like inside those passengers, there you're looking for a security breach, somebody trying to sneak something in. So you can be much, much more efficient and much, much more effective. And really, what this gives you is, better security and time back to your security team. Really, that's one of the best things that you can do, because stopping a breach, cleaning up a breach, ultimately that comes down to your network ops, your security ops team going and finding and fixing that. And we're giving you back time for them so that they can be much more effective in their jobs and make your network much, much safer and definitely lower your operational cost. And that's it. And one more quick survey here. Over to Alexander from that, and then we will open it up to Q&A.
Great. Thanks, Scott. That was such a great presentation. After learning about ThreatArmor, what do you think about it? Do you think it's the coolest thing since sliced bread? Do you think that ThreatArmor is the coolest thing since aerosol cheese? Or maybe you think that it's the coolest thing since the self-flushing toilet?
Full disclosure, I may have had a hand in crafting these survey questions.
All right, I'll give you guys just a few more seconds here, and then we'll open it up to questions. All right, you'll be happy to know that 52% of the votes think that ThreatArmor is the coolest thing since aerosol cheese. Second is 26 think that ThreatArmor is the coolest thing since the self-flushing toilet, and 22 think that ThreatArmor is the coolest thing since sliced bread.
Wow. See, again, a regional difference, because up until now, the self-flushing toilet has been in the lead. Okay, thanks. So now we will open it up to Q&A. It looks like we've got a bunch coming in. So Alexander, I'll let you tee off with those.
Sure. Looks like we have a question asking, does the ThreatArmor app support Apple Watch or Android Wear?
We don't today, but that's a great idea. It would be pretty easy to extend it. I guess it might make sense. You're getting, you're doing blocks all the time. What might make sense, and what we have had requests for, is kind of threshold. If if you suddenly get a massive, kind of spike of blocks, especially for maybe outbound things, which would indicate a botnet infection or something, that might make a lot of sense, because that's the kind of thing where you would need kind of immediate proactive notification. So that is a great idea. I'm going to take a note on that and talk to engineering about it. So no, we don't yet, but thanks for that question. We might soon. That's a great idea.
Great. How could I use this in an AWS deployment?
Oh, okay. So that's a really interesting question. So and I think there was another one about virtualization. So we are working on a virtual version of the product right now. In fact, we're in trials with it at some service providers, especially like managed security service providers. The AWS question is really good. So certainly technically, we'll be able to work in that kind of environment. I mean, we certainly can. I think the real question is does it make sense there? Because typically you're going to get the best gain out of ThreatArmor when it sits between your users and the internet, because users are the ones who are likely to click on a phishing email or have like a tablet or a laptop or whatever that gets like a malware infection, a botnet infection that's stealing credentials or doing keylogger or frame grab or whatever and shipping that information out. So typically you're going to get the most benefit in front of users, as opposed to something like a server, a web server, where something like a WAF might be a more appropriate kind of protection. So it's certainly something that we're looking at and that we technically can do. It's just not clear to me yet that it's the best kind of use case for this deployment model, but we're working on a number of cloud projects, and we certainly should have the virtual version of this out certainly within the quarter. And so that's a use case that we will look at and maybe do some trial deployments and see if it makes sense, or maybe we want to tweak a little for the cloud. But technically, we will soon have a product available that would let you do that. So that's a good question.
Great. Another question is, do you offer threat hunting processes for staff, either through managed services or training?
So that's a good question. So we don't offer managed services ourselves. We have a lot of MSP partners, certainly a lot of the larger ones that who kind of take and resell products, including ThreatArmor, and build services around those. We work with large system integrators, managed service providers, things like that. We do offer training, especially around, we have training for what we call cyber range training, where you can operate a full, red team, blue team. You can learn about how to do threat detection, and so we can use our test products to generate very, very realistic traffic and do everything from kind of capture the flag to, okay, here's a flood of alerts, here's a flood of Facebook and whatever traffic. Can you spot the bad thing? Can you spot the infected device? Can you spot a breach? So we certainly have training available through our professional services organization. I'm sure there's a link to that on the website under services, but the specific thing that I think you'd be interested in for that would be our cyber range training, because that's really what that is. That's focused on is, not so much product, but people and processes, and making sure that, hey, you've set up your firewall, your SIEM, your whatever. And it may be good stuff, and we can certainly help you with device selection, but it may be great stuff. But when the lights start blinking, when there's a problem, do you know how to respond? Do you know how to find the breach? So we absolutely have training exercises around that.
Great. Can you decrypt SSL packets?
Ooh, good question. So so we don't do decryption on the fly, and in fact, if you think back to where I was comparing sort of what ThreatArmor does to what a firewall does, we're not trying to do DPI. So we're not trying to inspect the contents of any particular connection. We do our blocking on a per IP basis strictly, except for the cases of multi-hosting, where a single IP can represent maybe tens or hundreds or potentially thousands of different domains. In that case, we go beyond just the IP and look at the domain that someone's trying to connect to, and then we see, okay, we see malicious activity from that particular domain or not. So where we really do our, kind of malware inspection and detection and reversing and things like that is in the cloud. So we get thousands of new malware samples every day, and we reverse them, we unpack them, run them in a sandbox, we see who they connect to, so we can know, okay, where's it phoning home to. We'll do things like crank malware up, pause its execution, scrape memory looking for encryption keys, and once we have the encryption keys, we'll reverse engineer the communication protocol that the malware is using to phone home. So once we've done that, then if we see a piece of malware connect to a site and we want to see, hey, is this really a controller, then we can launch our own process and communicate with that site with its own native communication protocol and encryption scheme. And then we know, oh, yes, this really is a botnet controller. This really is a bad site. But that's all done in the back end. That's part of the cloud information. So when a connection occurs, let's say something's trying to connect in or off of your network, and that connection is encrypted, we don't care. We're going to stop the connection at the first packet based on the fact that it is going to a site that we know is today, hijacked or actively distributing malware, or is a phishing destination, or is like a probing or scanning site. So we're not trying to decrypt the connection. We can block it just based on our 100% knowledge of that site being bad.
Great, and I think we have time for just one more question today. And if we have our own list of blocked IPs, how many of these can you import?
You can do several 100,000. I think it will support, I think it's blocks of 100,000 at once. So you could do like 4 imports if you had 400,000. If you have smaller numbers, like in the tens or hundreds, the easiest way to do it is through the REST API, and there's actually great documentation built into our API. You can literally copy and paste the commands to and just build your own script or something around that. But if you have a huge set, I know we've tested with several 100,000, but and like I said, we can block in the billions. The individual imports are about 100,000 each. If you need more details or you want to figure out how to work something out, again, it's sregister@ixiacom.com.
Great. Well, I think that's all we have time for today. And I wanted to thank everyone for joining us. If you have any questions, please feel free to contact Ixia at contact_us@ixiacom.com or reach out to Scott directly, sregister@ixiacom.com. Or if you have any other questions, you feel free to reach out to me. You should have my email from your registration emails, acassandro@ixiacom.com. Thank you so much again, and we look forward to seeing you all on another webinar. Thank you.
Thanks for joining, everyone. Have a great day.